Good morning everybody. So yesterday we saw in the types of pits, in that we saw yesterday clearance pit, isn't it? We saw the clearance pit. This you don't see now, you see here. So yesterday we took one example, 20x7. So capital letter it belongs to hole and small letter it belongs to shaft. So from the table, if you see from the table, it is already there in your textbook. So x7 means it is 20 plus 0 and plus 21 microns. Okay. This belongs to clearance pit what I am explaining now. Plus 0 and plus 21. G6 in the sense 20 minus 7 microns and minus 20 microns. So just if you going on, you write the sizes. Okay, you can do the any combination of these. You can do any combination. On the whole, you can do 20. You can do this for 19.99. But everywhere, if you see now, here tolerance zone of the whole, always it will be above the shaft. Okay, you see 19.993 it starts. Okay, minus 7 in the sense 19.997. So directly it becomes 0.007 clearance. Got it? So it is above. So schematic view yesterday I said, okay, always your tolerance zone of the hole. Okay, tolerance zone of the hole, it will be above the tolerance zone of the shaft. Tolerance zone of the hole will be above the, so schematic view we have to show clearance in the sense hole will be above, shaft will be below, like this. Okay, always keep it in mind. So like that you can, hole is bigger, because when it comes for interface pit, this will go above, this will come down, so you will be confused. So you think in the clearance pit hole in the sense big. Big means it is more, so it is coming above. So like that you have to remember. So here like it will come. So you can see here somewhat in all the combination I didn't write here. Up here 003 again 004, 005, 006 like that it is coming up to 021. So any combination you see, any combination, this you can do, this you can do, this and this you can do, or this and this you can do, this and this you can do. Any you do, but here there is a clearance. Okay, there is a clearance. So that is why it is called as a clearance pit. So just if you take a hole and if you shaft if you do, just by if you put it dash to enter. Okay. So here minimum, okay, minimum clearance we will get actually in this example we will get the minimum clearance. It is the maximum of the hole. Okay. This is I am repeating yesterday. Okay. So you will get the minimum clearance. Maximum of hole 20.021 and minimum of shaft. Okay, maximum of hole, maximum of hole and this is the minimum clearance. Okay, maximum of hole and maximum of shaft. That time you will get the minimum clearance. Okay, you will get the minimum clearance. So it becomes 19 minus 19.993. So is equal to you will get the 0.007 mm. Okay, this is the minimum clearance. Suppose if you want maximum clearance, maximum clearance if you want to hear what you have to say, maximum clearance, freely it will go. Okay, shaft you do not have to put little press like that, nothing, freely. Just if you insert now, suppose if you are hole you are drilling and you put the bolt and nut, is it dead? Bolt just if you insert it will go, is it dead? There is a full clearance, it is in that in the hole and only about 0.1, 0.2 clearance will be there always. When you assemble a bolt, suppose M10 bolt is there means always you are drilling in 10.2. Directly if you put 10 bolts, easily it will go. Same thing here you see maximum clearance means maximum of hole. So 20.021 clearance 20.021 minus minimum of shaft. Okay, minimum of shaft is the 19.980. So we will get the 0.041. Okay, 0.041 clearance will get 0.04 you see, easily it will go. Not 0.1, 0.2 and all. The bolt and all it is a point on point easily, but this is a 0.4, just slide, just it is moving like that. Okay, that's why in that always we are giving the tolerance in the fitting 0.04 mm, that means your fitting has to just, it has to slide. ನೀವು ಕೆಲವರಲ್ಲಿ ನೋಡುವಾಗ ಏನಿಲ್ಲ ಸ್ಲೈಡ್ ಹೋಗುದು. Okay, isn't it? Some of you fitting, if you see directly, if you put, you can see all the gap, all and all you can see nicely. It is not like that. 0.4 gap means 0.4 gap, you cannot see nothing. Okay, just it is going to slide, that's enough. Okay, that much is enough for you know. That is about belongs to clearance bit. So today we will see about now interference bit. Okay, we will see about interference bit. So this is the second one. Okay, second one. This is the interference bit. Here, if you see the drawing, here you see, here it is always your shaft is bigger than the hole. Okay, always your shaft is bigger than the hole. So this is the schematic view. Always it is coming like this. This is the shaft. This is the hole. So schematic view of a interference bit is like a shaft. It is always your dominant zone of the hole will be above. You see, you can see here. Now this is the bit. Okay, expression of bit 25x7 P6. Now it is now P6. It is changed now. You see. Actually in the clearance bit, actually it was 25G6. Now it is a P6. Okay, 25x7 bar P6. So 25 x7 in the sense 25 x7 in the sense 25 plus 0. Okay, plus 0, then plus 21 microns. Okay, interference. Now this, if you see in the chart, you will get the deviations. You will get the deviations in microns. Okay, plus 0 and 21 microns. If you see P6, okay, P25, P6, so it is a 25, 22 microns. Okay, that is in plus. Okay, plus 22, then plus 35. Okay, plus 35 microns. So size again I am not going to write here. So that's why 25x7 means 25 mm. Is the minimum size. It is I can maintain. You have to maintain 25 in the hole, and you can go maximum up to 25.021. Okay. Then if you see in the shaft, you have to maintain 25.022 maximum. That size. It is not a 0. 25.00 is not a 00. You have to maintain 25.022. Then you have to maintain shaft. You can go maximum up to the maximum. You can go 25.035. Okay. So here you see, you directly can see here 25 is the minimum possible in the hole. Adara keಳಗೆ ಹೋಗೋದಿಲ್ಲ ನಾವು. Okay, 25 is the minimum. Shaft itself, it starts from 0 to 2. Okay, it is a 0 to 2, it is a extra. 0 to mean the sense in the hand you cannot press at all. Okay, you can't imagine that 0 to. It is not at all possible. Okay, so almost it is coming in the bearing pit. Like this 0 to only it is coming. Okay, bearing pit in the sense bearing yaudu bolt nut and all you are not going to put. It is in the housing. Okay, there is a, suppose this is a housing. In this hole you are doing, and this is your bearing. Okay, this is your bearing. This is your bearing. So this size actually, suppose this is a 25 you are doing, and shaft always you are doing this. Sorry, this is the 25. Actually, okay, it becomes now shaft. This is actually bore. Okay, so bore actually you have to minus size. Now actually bearing and all it is coming exact size. Okay, bearing it is coming 25. Bearing it is exact is coming 25. But you have to maintain a interference fit means it must be always 0 to less. So what you have to do? You have to maintain 24.998. Okay, that is in microns it is coming 98. You can maintain 24.98. Okay, 0 to less. 0 0 to less 24.98. So 08 minus 25. So that time if you put no here, this is 25 more no. Just you have to press it by hydraulic press you can do, or else hammer also it is possible. You have to use a aluminum piece over the bearing, then equally you have to hammering also you can fix, or else you can go for fly press is there, one more fly press. So in that you can do. So anywhere, but by bare hand, by pressing it is not at all possible 0 to. Okay, so that is called actually interference. Always it is called as interference. So now you say here maximum interference and we see minimum interference. Okay, you see the maximum interference. Now maximum interference. Maximum interference in the sense your hole will be very small, isn't it? Okay, your hole will be very small and your shaft will be very big. You can maintain maximum, it is here, this is the maximum interference means, correct. Maximum interference, this is the shaft 25.035. So 25.035, that is called maximum of shaft. Maximum of shaft, and it is a minimum of hole. Okay, maximum of shaft, minimum of hole. Maximum of shaft 25 point. If you want, I'll write. Okay, that notes in the notes I will send. Okay, you copy from that notes as it is, will come to know. So the maximum of shaft 25.035 and minimum of hole is minus 25. So is equal to, it becomes 0.35. This is the maximum interference. Okay, 0.035. It is the maximum interference. Now, if you want to minimum, okay, minimum interference. It is a maximum of hole minus minimum shaft. Okay, minimum shaft. So minimum interference means maximum of hole. Okay, maximum of hole you can maintain 25.021. Sorry, 25.2. Okay, 0. Sorry, 1 minute. Maximum of shaft. Okay, maximum of shaft. Sorry, maximum of shaft. Okay, maximum of shaft and minimum, maximum of shaft and maximum of hole. Okay, maximum of shaft as well as maximum hole you can do, so that time you will get the minimum interference. So maximum shaft, maximum hole. So both same. Okay, maximum of shaft, then maximum of hole. Okay, maximum of hole. So maximum of the shaft we can maintain 0.35. Sorry, one minute. Minimum it is possible. Minimum shaft you can do this much. Then maximum hole. Maximum of the hole. Okay, 0 to 1. So minimum of the shaft. Okay, minimum of the shaft. Minimum of the shaft. Okay, minimum of the shaft minus maximum of hole. Okay, minimum of shaft, then maximum of hole. maximum hole. So minimum of the shaft is 25.022, 25.022 minus maximum of the hole you can maintain, it is at 25.021, 25.021. So is equal to, it is a, will get only 0.001. Okay, this is the minimum interference. Minimum 001, 1 micron. That little by 200 grams hammer, if you hammer, no, it will go like that. Okay, 1 micron, 200 grams hammer. Aluminum tips are really used or shaft only by 200 grams hammer. If you use, it will go. Again 0.1. Okay, 10 microns it comes means 0.1 means 200 grams. It is not at all sufficient. You have to go for 500 grams. Got it? Again 0.2 means actually 500 grams not sufficient. You have to little increase the weight of the hammer. Like that. Like that interference will come. So like that heavy interference with still it is there. Okay, what is the that I am not telling now. One is the expansion fit and one more is the shrink fit. Okay, that I will take next in the class. In that too much of interference is there. Too much about 0.1, 0.2. Okay, about 1 mm also is there. In the ship building and all, if you see, no, the ship building, the big your bearing itself such a bigger diameter. Okay, 1 meter diameter like that, such a big. So that all what by hammering and all it is not possible. Okay, so that is one expansion pin. What means what hole is there? No, hole that going to. So when you heat a job, what happened? It is going to expand. So your hole will be heated. Okay, hole will be heated to about 800 degrees centigrade. Then your shaft just it is heated means it is going to expand. Directly can enter the shaft. Okay. So when it is cooling, when it is coming to the room temperature, what happened? It becomes a tightly it is going to fit. Okay, that is the interference. One more is the shrink fit. Okay, shrink fit means what? Shaft is there now that you have to going to shrink. So as on when you heat your job, is going to expand, isn't it? Same thing if you defreeze. Okay, for that gas and all you have to use. Okay, some gas and all you have to defreeze. Fully you have to cold. Okay, you have to full cold condition you have to get. What happened that time? Your shaft is going to shrink. Your shaft is going to shrink. Then what happened? Directly it is assembled to the hole. Okay. Your bearing is going to you have to shrink. Bearing if you heat means it is going to damage. That's why it is they are going to do. They are going to shrink it. That is going to reduce. Then you assemble the bearing. When it is coming to normal room temperature, it is tightly going to fit in that hole. Okay, like that. So since that is now you don't want that, I will explain later. Okay. So like that. So this is actually a schematic view. Remember. Okay, always shaft will be above, hole will be below, and here always your tolerance zone of the shaft is above the tolerance zone of the hole. So that you keep it in mind. So one more bit is that I will see. Last bit that is called transition bit. Third one, it is called as a transition fit. So here transition fit here in the sense here what happens here it is a sometimes in this fit. Okay, sometimes it is a clearance also it is there. Sometimes it is a interference also is there, and sometimes it is going to overlap. Okay, 75 in the sense both it is coming 75. So now that one fit example I will show you, that will see, that time you will come to know. Okay. So if you want a schematic view, okay, if you want a schematic view, see schematic view of this is a hole. Okay, this is a hole. Hole will be above and your shaft will be below. Full ಜಾಸ್ತಿ ಬರೋದಿಲ್ಲ ಆಯ್ತಾ ಸ್ವಲ್ಪ. Your shaft will be below. So this is actually called, sometimes it is a clearance. Got it? Sometimes it is a clearance shaft. This is the schematic you remember and you should able to draw. Next if you see here hole, this is the hole. This shaft what happened, it is going to overlap. Got it? The shaft is going to overlap. Sometimes what happens, it is going to interfere. This is a hole and your shaft is going above. Okay, shaft is going to above. So that's why it is called as sometimes it is a clearance, sometimes it is a interference, and sometimes it is going to overlap. So that's why it is called as a transition pit. So schematic view of the transition pit is this. Okay, schematic view of the transition pit is this. One example, just I will draw a little bit fast. Okay. So one will take 75. For that this will take expression 75 H8 bar J7. Okay, H8 bar J7. So if you see H75 H8, okay, 75 H8, in the sense you will get the deviation from the chart. You will get the deviation from the chart. 75 plus 0. You almost H is there. H means almost it is coming 70 0 only. First deviation almost it is coming 0. Okay. Can't say sometimes, but almost it is coming 0. Plus 0, then plus 46. Plus 46. Now J7 in the sense 75 J7. Okay, 75 J7 means 75. Here you see now plus 18 microns minus 12 microns. Got it? See 75 H8 means plus 0 plus 46. Plus 18 plus 12. See here also 75 is there, here also 75 is there, isn't it? So here definitely it is one place it is coming exact 75. Got it? See 75.001, 75.002, 75.003, 75.000, 74.999 minus sign. Understood that will be. Schematic view you see, okay, you understood the schematic view. Okay. This you can write now. You see, you can write 25 plus 0. That figure and all I won't draw. Figure it is there in your book. Okay, which you have to copy. I will tick mark. I will do. Okay, that figure you have to copy from your book. Okay, again I am not going to draw because there is a shortage of time. Okay, so we'll say now 75. Okay, you can do 75.00, 75.001, 75.002. 75.003, like that. 75.046, isn't it? 46 microns. 46 001 into 46 micron in the sense it becomes, you see, isn't it? So 75.046. Maximum we can go 75.046, or else next we can go 75. Somewhat I will do 75.043, 75.044, 75.045, 75.046. Got it? You can maintain the whole. You can maintain the whole size from 75 to 75. So many are there in middle. Okay, 75 to 75.046 you can go. Understood? Now this is the X7. Okay, 75 X7. Now 75 J7. J7 in the sense you see it is in lesser side. Okay, maximum we can go size. Maximum I will write and minimum I will write. So maximum will can go 75.046 0.018, 18 microns. Okay, 18 microns, 0.018, 75.017, 75.016. Okay, next 75.16, 1514. Okay, 13, 12, 1 like that, 12, 11. Like that, last it will come 75.001, isn't it? 001, 002, 003, 009, then it is coming 01. Got it? Like that, you are going on multiply, you come to know. Just you add microns. Okay, 1 micron you add, you come to know. So it comes 75.001 and it is coming now here 75.00. Got it? It is going to overlap. It is going to overlap. Got it? Here you see sometimes it is 75. Again now you see it is coming minus side now, minus 12 microns. So it becomes now next time 1 by right 74.999. Okay, that if you want to calculation you want to, it is just you see 75.000 minus 1 micron 001. Isn't it? 10 minus 1 9. Here it is a 9. Here it is a 9. Here it becomes 4. Isn't it? 74.99. 74.99, 74.998, isn't it? This is going to reduce 7.998. So like that it is having now 74.988 last. Okay, last it is coming, last size 74 point. If you deduct, nothing is there, you can deduct and you can see 75 minus 12 microns. Okay, 001 1 micron is equal to 001. So it becomes 12 microns in the sense 012. Okay, 0.012. 10 minus 2 8. 9 minus 1 8. Here it is at 9. It is at 4. So it becomes 74.988. Then it is at 74.989. 74.990. Got it? So like that you see, combinations you see. So here it is sometimes what happened, it is going to overlap. Sometimes now here it is 75. 74.99 it is a clearance. It is a clearance bit, isn't it? 001 clearance. 75 it is all, after this all it becomes clearance. Got it? Now you see here interference you see. Now same 75 you see. Sharp is 70.018. It is the interference. Isn't it? 018 more no. It is a 75. So it is a, sometimes it is a clearance, sometimes it is a interference and interference and sometimes it is going to overlap. So this type of fit technical it is called as a transition fit. Just slide agligirtade. Slide. Okay. 75 exact ಮಾಡಿದ್ರೆ ಆಗುದಿಲ್ಲ 001 1 micron clearance required. Okay, just slide ಬೇಕಿದ್ರೆ even if you need sliding means 1 micron clearance required, then you can do the sliding, just sliding. Okay, that are possible. So this combination if you want yourself you can write and do. Okay, figure it is there in the book too that you can copy. So in this if you want, now can you tell me, can you imagine maximum clearance? Okay, maximum clearance how much? Okay. 75 H8 per J7. Okay. So 75 here assignment plus 0 plus 46. Here plus 18 plus minus 12. Okay, minus 12. Now it's a maximum clearance. Maximum clearance, minimum of shaft Okay, minimum of shaft and maximum of hole. That's enough. Maximum of sorry. Yeah, correct. Maximum of hole and minimum of shaft. The maximum of hole you can maintain 0.46, 70 maximum of hole. Minus minimum shaft. So maximum hole it is a 75.046 minus minimum of shaft 74.988. Okay, is equal to 0.46 and that and to 988. So we will get to 0.58 mm. 0.058 mm. Okay, this is the maximum clearance. Okay, now interference we will see. Okay, maximum clearance. Okay, now here maximum interference. This is the maximum clearance. Okay, maximum interference will get what? Maximum maximum interference means what? Maximum interference, it is a minimum of hole. Okay, 75. 75. Okay, this is the actually minimum of hole. Okay, minimum of hole. Then maximum of shaft. That is the maximum interference. Okay, maximum of interference. 75.018. So actually 0.018 mm. This is the maximum interference. Okay, maximum interference. So it is the maximum of minimum of hole, and it is the maximum of the shaft. Okay, minimum hole and maximum of the shaft, you will get the maximum interference. So that is there in your textbook, because it is a question, it will be asked definitely. Choose the correct answer, question will be asked definitely, so you should be able to answer it. Okay, so that's why you have to study. This is a little bit understanding, it is a little bit difficult, so you have to work hard. You study, going on, write and do, so then it will be very easy, no problem. Once if you understood, nothing is there. But you have to imagine directly, blindly you can't say the answer. Okay, you have to write and you have to tell the answer. So you have to imagine first of all. Okay, don't go for to tell blindly, it is there. So then there are two systems. Okay, there are two systems. One is the hole basis. Okay, that I will take one more class tomorrow. Okay, one more video I will send. But how to read the chart in British system? Now metric system chart is there. British system little formula is there. So that also is there. So that class I will take tomorrow. Okay. So this you write the notes I will send now. Video I will send. See properly. Then write the notes properly. Going on, complete it. So yesterday I saw in the WhatsApp also. About 3-4 name I won't mention now. About 3-4 of you have not to visited that site. I can make out here. You have not seen also. Okay, you have not seen the notes also. 3-4 are there. Okay, I won't mention. Today I will see again. So be careful. You write because there is no other work for you now. Because situation is such. Okay, COVID, isn't it? So what happens now? Immediately when you come now, I think your first year is over. Your first year is over. When you are coming to the institute now, it will be starts from second year. So whatever now first year is there, directly when you are coming here, I am going to conduct an exam directly. Directly I am going to conduct an exam. So write your notes and properly now only. Okay, don't keep pending. As on when you will get the messages from WhatsApp, immediately you write the notes. So don't keep pending. Okay, we'll see tomorrow. One more video I will send tomorrow. Okay, bye.